Good afternoon. My name is Bruce Payette. I'm going to talk to you about PowerShell proxy functions. I didn't actually make an agenda slide for this because the agenda is very simple. What, how, and why, or what, why, and how. What are proxy functions? Why do we care? And how do we use them? Thanking, as always, our sponsors. I did finally get a chance to talk to the Jane Street guys. It was awesome. So I'm Bruce Payette. I worked on PowerShell. I worked at Microsoft. I wrote a book. Moving on. So, what's a proxy? Proxy is something that acts on the behalf of another. And this is a Wikipedia definition again. So basically, you want to use something as an intermediary between you and a command. And why do we care? So what a PowerShell proxy function? It's an advanced function that presents a commandlet-style interface on top of underlying functionality. Proxy functions can wrap existing commands to either augment, that is, add new parameters, or restrict by removing parameters. And it depends on command resolution order. So functions are resolved before commandlets. So you can create a function with the same name as a commandlet, and it will be activated first. And yes, this is the dreaded metaprogramming thing that comes up every once in a while. So core proxy function scenarios, the biggest one is role-based access control. And this started right at the very beginning of PowerShell when we were working with the Exchange team. They had a model around doing role-based access control through restricting the set of commandlets and restricting the set of parameters on commandlets. So the ability to generate these commands automatically was really important. They're also used in explicit remoting. So you can get the metadata from a remote machine and synthesize a local command that automatically takes care of the remoting. This is also what the Windows compatibility module did. It used an out-of-process PowerShell host, so you could call PowerShell commands inside PSWH. And then the last one is exposing data sources that don't look like commands. So SIM in particular, the SIM commandlets allowed us to automatically generate tons and tons of commands without a lot of extra effort. So there's some more scenarios. Those are the core scenarios, but there are other scenarios like say you want to add extra logging to a command. Then you can create a wrapper that does that logging and then calls the underlying command. Memoization, isn't that a great word? It's a fancy word for caching, so that you can have a slow operating commandlet, and then you can generate a wrapper around it that will cache responses and return them immediately. So, implementing rollback. G is another one where we use the proxy functions as a way of restricting capabilities. Okay, so in order to make proxy functions work, we have to have the three sort of fundamental things that you have in a command. You have parameter passing. You need to be able to do streaming. That's really important. And then you don't want to write a lot of code by yourself, so you want to have code generation. Okay, so step number one, propagating arguments. We need a way to pass the arguments through to the proxy function, from the proxy function to the wrap function. And the mechanism we have for this is $PS bound parameters, where the actual arguments to a function are bound to a hash table or a dictionary that can then be passed to the nested command through splatting. Streaming behavior, you could just use the PowerShell API. I'll show how you can do that, but that's not what we use. Instead, we use steppable pipelines. So this is the ability to take a simple pipeline and turn it into something that can be orchestrated by the calling process or the calling function. So these are called steppable pipelines. Steppable pipelines, they allow a pipeline to be stepped through. So you can call begin, you can call process, and then you can call end. They represent essentially a reified, that is made concrete computation. It's fully compiled and waiting to execute. And note that steppable pipelines are purely pipelines. They only contain commands and pipelines. They don't contain any language features. Okay, enough with the slides. So one of the things that we provide to make it easier, I talked about code generation very briefly, is that we have can you see that? Is that big enough? Yeah. Okay. So first, we provide a set of interfaces to generate proxy commands, which are static methods on a type. So here we go. It is obviously named proxy command. Let's see what the proxy command can do. And so these are the APIs. There are obvious ones that create, these generate the complete code for a function, but there are other ones, fragments of the function that you can generate at will. So you can generate them from a command information object or command info object. And you end up with a large piece of text, which you don't have to write. But you can see the referencing steppable pipelines, and then where's PS bound parameters is splatted here. And you can get individual pieces, as I said. So here we're just getting the commandlet binding fragment of code. And so you can use, rather than generate the entire function yourself at once, you can use this to generate bits of functionality and intersperse function code that you want to run in the command in between all this other stuff. So you can do it with command info objects, but command metadata is actually much more flexible. Command metadata is a way of getting the command metadata from a function. So all of the stuff that when you're defining an advanced function, all of the attributes and so forth are part of the command metadata. So here's what a command metadata piece of metadata looks like. There are interesting things, the type of positional binding, parameters, where's arguments, the name. So all of these different pieces are available. So here you can see a list of all of the parameters to the underlying function. Now, if I want to edit that function, I can simply call the remove method on the underlying metadata object and remove depth. And now when we look at, and it returns true because it successfully retrieved or removed the depth parameter. And now, so let's look at the parameter object again. And you can see that the depth parameter has been removed. So you can use this to pick and choose which parameters you want to be available in the commandlet. And then once you have the parameter metadata configured the way you want, you can turn that into a proxy function. And as before, it's just it's a string. So since it's a string, you can't execute it directly, so you have to turn it into a piece of code. One way to do that is to create a script block. And so there it's executing the underlying command, which is get child item. So I talked about, actually the first step was dealing with PS bound parameters. So here's a small function that just writes, it has 3 positional arguments, and it writes those out using PS bound parameters. So you can see that the formal arguments get added as a list, returned as a list. I know what I did. Yeah, so if you actually look at the type of a PS bound parameter, it's a PowerShell parameter collection dictionary. Here, because I'm returning it as an array, it tells me that it's an array of object. Okay, so that part's easy. Most people have, well, I don't know, who has used PS bound parameters? Oh yeah, a bunch of people, so that's cool. But now we get into the interesting part, streaming. You don't want to have a wrapped command not return anything until the very end of an execution. So first we can do it with the PowerShell the PowerShell API, which is intended primarily for use by programmers, but you can also use it from within PowerShell. So that's a simple commandlet that runs get child item with invoke. Obviously, you can build more complex commands. And I realize I have a typo in here. Okay, live coding. That's awesome. So here I've got again, getting child items, but I've added a second command to sort them, and it takes the argument on the name of the property to sort on. So that's pretty cool, works fairly well. Slight diversion, this API lets you do other things like concurrent run spaces. So we'll quickly create a run space, and we'll open it, which is a step that I always forget. And now we'll create a pipeline. The difference between the previous instance and this example is I'm actually passing the run space to create. Originally, the API didn't have that, which was dumb. We fixed that, finally. Right, so now I've created a command that I can execute concurrently. So I will invoke it asynchronously, and it returns an instance of a task object, which is sort of the core of certainly C#'s approach to concurrency. And so let's wait for it. And now let's look at the result. And there again, we have our sorted list of files. So this is what thread jobs does basically. It allows you to create and execute things concurrently. So with a little bit of slightly advanced coding, you can build your own thread job function. So that's the PowerShell API, and that's intended for C programmers or C# programmers. But it doesn't quite get what we want. It's a little clunky. It's a little expensive. So there's a second API, which is a method on a script block that gives you something that's called a steppable pipeline. So let's take a look at that. Yay, it's a steppable pipeline. More interesting, let's look at let's see how we can run it. Okay, so now I have my steppable pipeline object. So these are the various. Now you can see right away the pattern that's there for advanced functions: begin, begin, end, process, clean, which was added relatively recently, and then the dispose pattern. So let's make it run. And then, so this is run because it's not taking any input. Passing false to begin says that this commandlet's not going to take any input. So everything gets run at the end. So now that I'm going to call end, we get all the sorted files. But more interesting, more useful. So here we'll create a steppable pipeline, but we won't tell it that it doesn't have any input. So this time we call it passing true to begin so that it does have input. And now what we can do is execute each pipeline iteration individually. Never mind. You're actually not getting anything because sort accumulates all the information, sorts at the end, and then returns it. So I broke my example by adding sort. Bad me. And then when we hit end, again, it runs. Let's try this a little bit more usefully. Apparently not. take out the sort. And now when we call process, oh, my rats. Yeah, so this example, we'll pass in, we're still using sort here, and we'll pass in a set of numbers and do the sorting in the end. So let's run that. And so you see you get the 1, 2, 3. And this actually has 2 commands. So it selects the first 3 items from the sorted list. And you contrast this with using the PowerShell API. This is a much more natural experience for the scripter. So you're simply writing a regular piece of PowerShell code and then calling get steppable pipeline rather than having to create a PowerShell object and then add commandlets and add parameters piece by piece. And again, proxy commands give you a string. And here's our nice long string. So it's a string. You can't execute it. We could call create script lock, but there's another, I don't know if I can call it a feature. There's another aspect of PowerShell where if you assign a string to a function drive name, you get a function out of that. There, you can see the function that's bound to that, or the code that's bound to that function. And let's try it out. Yay, it works. Very exciting. It also works with simple functions, so you don't have to use it on commandlets. The metadata thing only works for, the command metadata only works for advanced or commandlet functions. So we can create a little function foo. Everybody knows where foo and bar comes from, right? No? So effed up beyond all recognition, foo bar. And now we'll generate a proxy. Very simple, straightforward proxy. Again, we'll bind it into the function drive. And we'll execute it. If you will look closely, you'll see that I didn't call the second one foo. I called it foo2. And this is something you need to watch. You can, if you generate a proxy function that has the same name as the wrap function, you will be stuck in an infinite recurse, and it will spin until it crashes. Which is not a great experience. So for functions, you have to use a different name. If you are using commandlets, then you can use a like a module qualified commandlet name. So I can have foo in my current process or my current run space, and I can have my module / foo as the command I'm wrapping. And using the APIs is a little rough, so we can create a very simple function around that you can just make proxy functions from. And we'll create one. And then so there's our proxy function. Again, this should be looking pretty familiar by now. And then we'll run Zork. Okay, so that's pretty much that's the 3 steps, right? So we've done the parameter binding, we have done the manipulating the metadata, and we've generated the code. So we've done kind of all 3 steps. Let's look at some other places that this is used. Here I'm going to use a cmdlet to get the first couple of items out of the plug-and-play list of hardware. Now we want to look at the type of command that we have. So it is a function. We'll get the script block out of the function. And here, so this doesn't quite look like a regular command. It doesn't have the steppable pipeline. This is custom generated based on the Sim API. So if you want to look at it, you can use get command, or you can just use the function drive to do it as well. And then the second scenario is Memoization. This turns out to be much more painful than I had hoped that it would be. So we're going to create a command that's very slow. And now we'll run it, proving that it's slow. So it waits for a second, and then it returns the square of this number. In order to do memoization, so memoization, the idea is that for every input that the command receives, you look in a cache of pre-computed inputs and return the resulting value. Otherwise, you fall through and compute the value and then put it into the cache. So here we will have our global cache, and this is not good. It's a global variable. This isn't what you'd want. If you did it in a module, then you could have a module scope variable and not worry about people colliding with your cache. And now we'll define our function. But taking a look at the function, so here is the parameters. This was actually generated using the proxy command generator function, except that I used almost none of the code that got generated because this is a very simple function. So it cut everything down. Here's where it checks for the cached value and returns it if it has been cached. And then otherwise it calls it, caches it, and returns the value. I have become lost. Pardon? Yeah. Here we are. Okay. So I called it once and it was slow. I called it a second time and it returns immediately. So see if there's anything else I need to address. Yeah, so that's basically it. Okay, so we did the demo. I'm actually ahead of myself on this talk, which is interesting. So conclusions, proxy functions are useful for a whole bunch of scenarios, caching and logging, but they're still kind of a pain in the butt to use because you have to edit the text. It would be really interesting to have a proxy generator that took the AST and manipulated the AST. That would be a much more sophisticated way of managing the code rather than trying to edit text. You could also do things like, rather than caching, you could have a locally bound variable. So yeah, that's proxy functions. I got it in much faster than I thought I would. So any questions? Yes?
So you can capture unbound variables in your script block,
Mm-hmm.
in your function. Were there any conversations about capturing not unbound, like
Free variables?
parameters that weren't incorrect?
Yeah, that comes up periodically. One of the things that PS bound parameter doesn't do is it does not copy in. Oh, so the question is, can you catch parameters that haven't been specified? And the answer is this is an issue because you can have initialized parameters, and they don't get passed through. So that would be a thing that would be good to fix. Open a bug. Mm-hmm. Yeah. So, question? Yeah. Yeah. You do import Windows module, and then whatever the module you're importing is, and it generates proxy functions for everything that's in that module, and then does implicit remoting to the child process, not to another. It doesn't go through WSMan, so it's a little more efficient.
If you only have a PSConfEU object for another process separately, how would you go about generating?
Yeah, you do import module dash command dash computer or dash session should do it. Yeah. So yeah, that will do that. Anything else? Raymond? I'm just drinking my coffee, he says. Leave me alone. Okay. Well, if there aren't there. Oh, yes. Yeah. There are, so it's not completely seamless. If things throw exceptions and errors, then the behavior of the wrapped command may diverge from the behavior of the command that's being wrapped. So there are limits to this. Any Rust programmers in the audience? Yes. So I think where it would be really interesting would be to do something like Rust macros, where you get the AST and generate code. I think that would be vastly more flexible than the current mechanism that we have. But that's a task for another day. Okay. So if there are no more questions, thank you very much, and have a good rest of your con.